Alright, welcome back. So last time we looked at how to solve a series circuit, meaning try to fill in the missing measurements with the rules that we've come up with in our chart here. And in this video we're going to take a look at how to do that when we've got things wired just in parallel to each other. So we'll be working in this column here. So we take a look at this circuit here, and what we can see is that we've got, again, a resistor A, a resistor B, a resistor C, but this time they are wired in parallel to each other. Again, try not to call it a parallel circuit. We're going to say that these resistors are wired in parallel to each other. So we can start with that idea. So A, B, and C are wired in parallel to the battery. You could say to each other or to the battery. When you've got things wired in parallel, it tends to be a little bit more helpful to say what they're in parallel to, because sometimes they'll be parallel straight to the battery. Sometimes they'll be in parallel to a section of a circuit. So when they're in parallel to the battery, I'm going to say wired straight in parallel to the battery. When they're not, I'm going to say wired in parallel to each other, which will make sense when we get to some more complicated circuits. So here we can then go to our handy dandy chart here. And in fact, before we go to the handy dandy chart, see if you can't figure it out. I'll give you a second. Plot down and guess. What do you think? What are the missing voltages going to be? What's the missing current going to be? Take a quick guess. All right, well, let's take a look at our chart here. So we know that in parallel, each parallel branch just straight up gets the same amount of voltage. Regardless of resistance, we don't care. They're just going to get equal. So all three are wired in parallel straight to the 12-volt battery source. So that means we are going to get VBAT equals VA equals VB equals VC. All of them are going to be 12 volts. 12 volts to A, 12 volts to B, 12 volts to C. Now we can see that they're definitely getting different amounts of current. And so real quick, based on that, of the two currents that we do know, which one's the bigger resistor? Does A have more resistance or does B have more resistance? Yeah, C is going to have more resistance because when we apply the same 12 volts to it, we don't get as much current. We get not almost half the amount of current as we do from here. And with B, once we figure out that current, we'll be able to compare that as well. Let's move on to current, that is. So now we're going to look at current, and we know that current is conserved. So the current through all the branches is going to add up, right? So in series, we could have just said, 1.48 all around. But in parallel, we know those branches are going to add up to each other. And so that would look like this. The current flowing in and out of the battery is equal to the sum of the currents in each branch. So all three of those branches are going to add up combined to give us this 1.48. So we can just plug in the numbers we do know. We know we got a total of 1.48, and these two branches are taking up about 0.96 of it, right? So that's going to give us a total amount of current of 0.52 amps. Again, you're going to want to break that down. The simpler the math, the easier it is to make a mistake. So you're going to want to make sure you show your work as clearly as you can to make sure you aren't making those mistakes and skipping them in your head. But that's all there is to that. So you got that. What we're going to do now is, using this again as a guide, see if you can't tackle this one. So we'll give you a second. We'll pause it up and see if you can't come up with what the missing values are here. All right, let's take a look at the answer. So the answer here is very similar, right? So again, they're wired in parallel. It's the exact same type of circuit here. And we know that in parallel, the voltages are all just straight up equal. So if this one's getting 6 volts, that means everybody is getting 6 volts. You get a 6 volt. You get a 6 volt. You get a 6 volt. But here, because these are, this is where it can get tricky. In this case, since we've got all three voltages with all three currents being equal, well, that's got to be equal, right? That's got to be 0.44? No, they're wired in parallel, right? You got to add them up. But there is something equal here going on. If each branch is getting 6 volts and each branch is then creating 0.44 amps of current with that, it tells us something about these three resistors. What's it tell us? Yeah, they've all got equal resistance, right? We can do Ohm's law on each one. Voltage equals current times resistance. So voltage, 6 volts divided by 0.44 amps is going to get us the same resistance in each branch. That's all there really is to looking at things when they're wired in parallel. That's how we're going to use our equations and use our justifications when things are wired in parallel. And next, what we're going to look at is what happens when we get those other two types of circuits, and then combine those on top of each other as well. So that'll be in the next video. So hopefully that wasn't too bad. And if you got any questions, pop into a Zoom meeting, let me know, and we can figure it out from there. Have a good one.